How can you write and solve a multiplication or division equation? Let's look at an example. Juan sold 3 paintings for $45. He charged the same amount for each painting. How much did he charge for each painting? Define the variable before you write and solve an equation. Let x equal the amount Juan charged for each painting. Solve the equation 3x equals 45 to find the answer. What is the unknown in this situation, and how is it represented? What operation is used in the equation? The unknown is the amount of money Juan charged per painting and is represented by the variable x. The operation used in the equation is multiplication. One way to represent the equation is to use a balance. How does this pan balance represent the quantities in the equation? The 3 cubes labeled x on the left pan represent the 3x in the equation and balance the right pan of 45 cubes that represent the 45 in the equation. Notice that both sides are divided into 3 equal groups. How does this pan balance represent the solution of the equation? This pan balance shows the result of dividing both sides by 3. The pans remain balanced, so x equals 15. Another way to represent the equation is to draw a bar diagram. Let x equal the amount charged for each painting. The total amount charged is $45. The bar diagram represents the equation 3 times x equals 45. To solve the equation, find the value of x that makes the equation true. You can use inverse operations to solve the equation 3x equals 45. Which operation will you use?
Select your answer.
Dividing by 3 is the inverse of multiplying by 3. Use inverse operations to solve the equation. Write the equation. Divide both sides by 3. Simplify. To check, substitute 15 for x. Write the equation. Substitute 15 for x. Simplify. It checks. You solved a multiplication equation to find that Juan charged $15 for each painting. How do the quantities represented in the bar diagram and balance correspond to the equation?
Teresia uses her debit card to buy the same lunch every day. In 4 days, Teresia spends $32. How much does her debit card balance change each day? Let N represent the amount Teresia's debit card balance changes by each day.
We have the equation written for us. 4N equals negative 32 because 4 days she spends $32. And so they want to know how much she's spending every day since she's doing that same lunch every day. So we're going to do the inverse or opposite of multiplying 4 times n and dividing 4 on both sides. So they're going to divide 4 on both sides of the equation. Now the 4 divided by 4 is equal to 1, so we're left with n by itself. And then negative 32 divided by 4 is going to give us negative 8. And it's negative 8 because she's spending that money, and negative 32 is the total number of money she spent, which is going away. She no longer has that money, and that's greater than the positive $4 she's spending each day. So negative $8 is going to be the amount of money she is spending every day for 4 days. So she is spending, or her debit card balance changes by $8 every day. Total cost of tickets is T, so that's all of these. And then we have the $40 per student, and there are 15. So there's 15 of these square or rectangles, and they're all paying the $40 per student. So then we have the equation, which is T divided by 15, which is equal to 40. And so we're going to do the inverse or opposite of division to multiply 15 on both sides. When we multiply and divide, that cancels each other out. So it's T, and then we have 40 times 15, which is 600. So T is equal to 600. So the total cost of those tickets is $600.
Solve negative 28 equals 4 times P.
The bar graph shows that you have negative 28 to represent the entire thing, and you have 4 that represents 4 of the p's that you're multiplying. Then the equation is negative 28 over 4, or divided by 4, and then 4p divided by 4. Because we want to get our variable p by itself, we have to do the inverse or opposite of the operation in the problem. So we have 4 times p here. So we have the opposite or inverse is dividing by p. So that's why we're dividing by 4 on both sides of the equation. So then we have negative 28 divided by 4 is equal to negative 7. And then on this side, 4 divided by 4 is equal to 1. So we have 1p. So we could check it to see if what we have is correct. So we take the p and we substitute it with the value of negative 7. And then 4 times negative 7 is negative 28, which is exactly the same as what they had it equal to. So we are correct. Another way is to use a number line to model the equation. It says start at 0, and you move left by 4 to negative 28. So as you can see on the number line, it's counting by 4s. So we go over 4 until we reach 28. And then you count how many times you jump. So we counted 1, 2, 3, 4, 5, 6, and 7. So there are 7 jumps of 4 to the left to get to negative 28. So P is still equal to negative 7. Solve each equation. So I'm just going to solve one of them, and then I'm going to have you do the other. So we'll do A together. So A is m divided by negative 15 equals negative 17. So we have to get the m by itself on, so the only way to do that is to do the inverse of the division, which is multiplication. So we're going to multiply negative 15 on both sides. So we're going to multiply, and instead of putting an x, I'm going to make, because you don't want to get confused with your variables. So we're going to multiply by 15 on both sides of the equation. So the negative 15 and positive 15 cancel each other out. And you have m left on that side of the equal sign. And then negative 17 times m. I'm sorry, negative 17 times 15. And that will give us negative 255. And that's it. So you're going to do the same thing on B and D, is solve each equation. So I'm going to give you time to do that on your own.